So, welcome to Dashlec, and this is lecture series on fluid mechanics, and this is lecture number 22, fluid kinematics, part 1. So, let's get through the question. The question is like the first question: the velocity component in the x and y directions are given by u is equal to lambda xy cube minus x square y, and v is equal to xy square minus 3y4 y to the power 4. The value of lambda for a possible flow field involving incompressible fluid flow. Okay, this word is very much important, that is incompressible fluid flow. Okay, incompressible. So for incompressible fluid flow, what do we know? We know for an incompressible fluid flow, okay, we know that del dot v, okay, this is v is the velocity vector, is equal to 0. Del dot v is equal to 0. This we know for the incompressible fluid flow. Okay, for the incompressible fluid flow, we know del dot v will be equal to 0. So our v is given. Okay, this is our v. Okay, so what is v? Is basically v is, okay, u I cap plus v j cap plus w k cap. Okay, this is our v. In this, u is given and v is given. So u is lambda xy cube minus x square y. So u is lambda xy cube minus x square y. Lambda xy cube minus x square y. Okay, this is our u, and the v is xy square minus 3/4 y to the power 4. v is xy square minus 3/4 y to the power 4. Okay, this is so. For the incompressible flow, we need to make this condition to be satisfied. Okay, for incompressible flow, this condition must be satisfied, that is del dot v is equal to 0. So what is del dot v? Del dot v, okay, it is not visible. Del dot v is equal to del u by del x, okay, plus del v by del y plus del w by del z. Okay, this is del dot v. Here the w is not given, so we will assume that w is 0. So if we will use this, okay, so now here, okay, if I will write like this, okay, if I'll write like this, that del by del x of u is given in the question, that is lambda xyq minus x square y. So lambda xyq minus x square y, okay, plus del by del y of v. V is also given in the question, that is xy square minus 3y4 y to the power 4, xy square minus 3 by 4 y to the power 4. Okay, now I need to and the w as it is 0, so the del w by del z is equal to plus 0. Okay, plus 0 and okay, what is this basically? This is, okay, this is del dot v. Okay, this expression, this expression is basically del dot v, and we know for incompressible flow del dot v is equal to 0, and in the question it has been asked for incompressible fluid flow, so this expression will be equal to 0 or not. Okay, it will be equal to 0. Now let us solve this. So okay, first let us partial differentiate this with respect to x. So if we partial differentiate this with respect to x, then we will treat lambda and y as constant. So the first term partial differentiation with respect to x will be equal to lambda yq, okay, minus, okay, the second term if we'll partial differentiate with respect to x, then that will be equal to 2x into y. Okay, I think it is clear. I think it will be clear for you. Plus for the second term, okay, this v, okay, for this we need to partial differentiate with respect to y. So the first term, if we partial differentiate with respect to y, it will be 2xy, yes or no? Then for the second term, if we partial differentiate with respect to y, that will be equal to minus 3y cube. Okay, minus 3y cube for this, yes or no? Yes, and this term is equal to 0. So from here we need to find out the value of lambda. Okay, one thing we can do, okay, you can see here that minus 2xy and plus 2xy gone. Now lambda yq minus 3y cube. Okay, so lambda minus 3 multiplied by y cube is equal to 0. So this term, okay, basically this term is equal to 0. So if lambda minus 3 is equal to 0 and lambda is equal to 3, this is our answer. So lambda is 3, option D. Let's go to the next question. So this is our next question. The question reads like, a fluid flow is represented by the velocity field v is equal to axi plus ayj, where a is a constant. The equation of streamline passing through a point 1, 2. Okay, first of all we need to know what is the equation of a streamline. Okay, what is the equation of a streamline? Okay, first of all we must know what is the equation of a streamline. the equation of a streamline, okay, equation of a streamline is given by, okay, dx by u is equal to dy yv is equal to dz, okay, by w. So this is the equation of a streamline, okay. Here, so we have the velocity as v is ax in the question, ax I cap plus ay j cap, okay. So we can see that u is given as ax and v is given as ay. Yes or no? U is given as ax and v is given as ay. Yes or no? Yes. So now for the streamline, we need to make this condition satisfied to find out the equation of the streamline. Okay, this condition. So what is our condition then? Our condition is dx by u is equal to dy by b. Okay. I'm not writing the w term because the w itself is 0. W is not present here. So dx, what is the value of u? It is ax. And dy, what is the value of v? It is ay. So from both the sides we can cancel out this a, okay. Then our equation comes dx by x is equal to dy by y. Yes or no? Yes. If we'll integrate both the sides, okay, if we'll integrate both the sides, okay, if we'll integrate both the sides, then it will come ln x, okay, I'm writing here only, okay, I'm writing here only so that it will be convenient to you, okay. Ln x is equal to ln y plus a constant, integrating constant, okay. So now I will write the integrating constant in terms of ln. Let's suppose it is ln k, okay. Now, okay, so ln x is equal to, okay, this is ln a plus ln b, so I can write it as ln ky. Yes or no? Yes. Now I will cancel the log from both the sides, okay. So my equation comes as x is equal to ky. So this is my equation of the streamline, okay. In the question it has said that the streamline must pass through the point 1 2. So my equation must satisfy the point 1 comma 2, okay. So if I'll put the point in my equation, it will come as, if 1 is equal to k into 2, yes or no? Yes. So my value for k will be equal to 1 by 2. Yes or no? Yes. So what is my final equation then? My final equation will be equal to x is equal to k is 1 by 2, 1 by 2 y, which is equal to x 2x is equal to y. Okay, this is my final equation. Okay, so 2x plus y, 2x is equal to y, we can write it as 2x minus y is equal to 0. Okay, so the option C is the correct answer. So this is all. Thank you, and I really appreciate your time. If possible, kindly subscribe the channel.